if you have a population size of 10,000 and there are 20 different seats that need to be apportioned, divided, and doled out to the different states, then we calculate this standard divisor, it's called, D. And it comes from taking the total population and divided by the number of seats. And so 10,000 divided by 200, and that's where you get 50. Now, all of our other methods involve selecting a value of D that's pretty close to this divisor. It's off by a little bit. And the method it uses is, or the way that this works, if you remember last time, Hamilton's method is a method that uses fractional pieces here. And then we had a Jefferson's method and a Adams method that uses a modified divisor. And we always look at, you know, is the modified quota, how does it compare to, well, in this method here, we're going to calculate the geometric mean. And instead of rounding up or rounding down or rounding mathematically like we do in the other methods, we're going to round based on the geometric mean. So if the standard quota that we calculate here is greater than the geometric mean, then what we're going to do is take the upper quota instead of the lower quota. So we're always going to start this method with the lower quota, and sometimes we're going to move up to the upper quota. And in that way, we'll never violate the quota rule. And recall that the quota rule is that whatever method you use, you should allocate seats that are either the lower quota for a state or an upper quota. So for example, if you were to use a method that somehow found that we wanted to allocate 24 seats to state A, that would violate the quota rule because 24 is not either one of these numbers. All right, the first thing we need to do is to calculate the geometric mean. And you can see n here is the lower quota. And n plus 1 is one more than the lower quota, which is the upper quota. So what we're basically going to do is we're going to take these two numbers, n and n plus 1, multiply them together, and then take the square root. You're always going to end up with a number between 22 and 23. It's going to be very, very close to 22.5, a little bit lower. All right, so the first thing we're going to do, as we did before, we're going to take these 5 numbers and put them into a list. So get your calculator out and enter in, and we're going to clear out just a couple of lists. And we're only going to have these 5 numbers. And I'm going to have you replicate this here in a second with in a different context. All right. Oh boy. All right, so we put these numbers, which are the population sizes of the 5 states. And the way we divide all these numbers by the same common divisor is you highlight the L2 and then take the numbers in L1 and divide by 50. And you get all these numbers. We did this before, and those were the numbers that you see under the standard quota. When you divide the population by the standard divisor, you get the standard quota. It's the standard quota that determine the upper and the lower quotas. Truncate to get the 22 for the lower quota, add 1 to it to get 23. The upper quota is like rounding this standard quota up, and the lower quota is like rounding the standard quota down. So if you take 22 and round it down, you get 22. If you round it up, you get 23. Take 26.4, round it down, you get 26. Round it up, you get 27. So the upper and lower quota will differ only by 1. All right. Now let's do the geometric means. So what we have to put in here is n for each row, the lower quota, 22 times 23, and then we'll write the decimal here. It's going to be something like 22.49 and some change, something like that, all of these. This one is the same thing, square root of 22 times 23, because these two numbers are the same. This one would be the square root of 26 times 27. And this one would be square root of 30 times 31. And finally, the square root of 98 times 99. All right, maybe we'll round these to 3 decimal places. That square root of 22 times 23 is 22.494. So that'll take care of those two. The square root of 26 times 27, see, 26.495, we'll round to 3 decimal places. Square root of 30 times 31, 30, almost 30.5. And let's see, one more, the square root of 98 times 99. All right, I'm going to write these numbers down. Around them. All right, I have a couple of D's here because this is going to be my worksheet. So this would be the, these are modified quotas. I'll put the decimal in here and then we'll round them according to the geometric mean and then see if we don't get what we need down here, which is the 200 seats. So the first one I'd like to try is, we've already done the standard quota, so why not just try the standard quota like this? Because the numbers are already there. Here's the standard quota, and there's the geometric mean. So we're going to start all of these off at the lower quota. And we know that the sum of these lower quotas is 198. So ideally, we would want to increase 2 of these exactly 1. We just don't know which ones. All right, so that's our starting point. And here's how we make the decision. If the standard quota is larger than the geometric mean, then we round up, which means we go up to the next, we go up to the upper quota, and we take the upper quota as opposed to the lower quota. All right, so is 22.24 larger than 22.494? And the answer is no. This one is smaller than this one. So we keep the 22 without rounding up. Is this number here, our standard quota, is it larger than the geometric mean? Again, the answer is no. So we keep this number. Go on to the next one. Is 26.4 larger than 26.495? The answer is, again, no. So we keep this one. 30.3 compared to 30.4, is 30.30 larger than 30.49? No. So again, we keep this one. And then the last one is 98.7 larger than 98.499. The answer is, well, yeah, that's the only one. 98.7 is larger than 98.49. So this one, we go up 1 to 99. However, unfortunately, these numbers here, we only added 1 to the 98, so our total is 199, and we need 200. So this is an example of it wasn't even a modified divisor. We used the standard divisor, and it turns out that we're a little low. So the question is, where do we go from here? Do we choose a modified divisor that's a little bit lower than this, or a little bit larger than this? Well, think about it this way. If we divide, I'll do it down here, 11112, I guess I'll just put it like this. I'm just putting different numbers underneath here, 49, 50, and 51. We've already divided 11112 by 50 to get this 22.24 number here. But if we divide by a larger number, then it's going to make these numbers smaller. If we divide by a smaller number, like 49, it's going to make these numbers larger. And if these numbers are larger, then they have a chance to get larger than this geometric mean, which would make this one bump up. So if you're short, as we are here, 199 compared to the 200, you want to choose a smaller modified divisor. All right. Now, it doesn't have to be, 49, or it doesn't have to be really small. It just has to be slightly smaller. And you don't want to go all the way down to 49, because then this number here might jump up to 205. It might be too big. So just choose in very small increments. And let's choose 49.8 here, just something very, very tiny. All right, I'm going to go back to our list, highlight L2, and then I'm going to divide all the numbers in L1 by our new D, our new modified divisor, 49.8. And I'm going to write these numbers down, 22.329, 22.45, 26.506, 30.422, and 99.096. All right, so these now are my modified quota values. So I'm not going to look back here anymore. Those. I'm going to compare this number with this number. And if the modified quota is larger than the geometric mean, then we round up. Otherwise, we just stay round down, I guess, or stay at the 22. So this number here, 22.3, is less than 22.4. So we're going to keep the 22 here. We're not going to round up. We need these numbers to be larger than the corresponding geometric mean. And they're not. 22.45 compared to 22.49. Our quota is smaller, so we keep the 22. In the next one, we have 26.506 compared to 26.495. Well, this number is larger than this one. So instead of allocating 26 seats to state C, we're going to bump that up one and go to 27. And then we're going to compare these two. Is 30.422 larger than 30.496? And the answer is no, it is not. So we're going to keep this one at 30. And then finally, is 99.096 larger than 98.499? Yes, it is indeed. So we go up from 98 to 99, go up one. So we've gone up one here, and we've gone up one here, and we started with 198. So those will sum up to 200. So the seats apportioned, 22, 22, 27, 30, and 99, and that would give us a total of 200. So that was the last method that we didn't do last time, and I wanted to show you how it worked, just because it's how we do it now with our states. But instead of A, B, C, D, E, we have 50 states that are allocated electoral college votes and also representatives in the House of Representatives. Unfortunately, the U.S. properties, territories like Guam and Puerto Rico and U.S. Virgin Islands, they all get to vote because they're U.S. citizens, but they're not states, and so they don't get representatives. They don't get any of the 200 seats or any of the 435 representatives. They don't get representation in there because they're not states.